End of the day, you have exposure to these 9 core themes, say in first grade, and then you're revisiting them, but in different ways in second grade, and so on, fourth grade, fifth grade, all the way through eighth grade in our LabLearner program. And by the end of that collective experience, then what they have is this large database and understanding of knowledge where they're connecting from the very basic level within a theme to the more advanced. Let's explore that a little bit more. In our next slide, we're going to take a look at this using some examples with real unit titles from the LabLearner program. I think an important point to make here, though, is that all of this is happening behind the scenes. So you don't have to be worried about concepts building from grade to grade. That's all built into the program. So as far as your grade to grade interactions, they can be really at that student level, and the curriculum and the systematic approach is taken care of for you. And that goes right into the design of the curriculum itself. So we've talked a little bit about the theory and the research behind this. Let's explore what this looks like on a day-to-day basis. Structurally, the LabLearner program is a comprehensive program. So this is not designed to be supplemental. The idea here, this is your core science-based STEM solution. So certainly it is your science curriculum at the school level, whatever grades that you go with. Now with that, it's all inclusive from another perspective as well. This program is designed to stand on its own. So when you're looking at cost considerations, one of the things you need to factor in is you're getting a full laboratory, you're getting curriculum for your whole school, you're getting on-site teacher training and ongoing teacher training. You're also replacing your textbooks. Everything is worked into a single solution. At the student level, the textbook is replaced with a student data record. This is really a workbook, and they would have one of these at each unit level. This workbook acts as both their content, it's also their lab book where they're recording their results, and then there's also your post-lab work and analysis. That's where a lot of the cross-curricular nature of this gets into play, where they're doing some of their math work, or they're using their ELA skills and describing their results. At the teacher level, you're going to be using something called a teacher manual. The teacher manual, you'll have one for each unit, and that has all of your lesson plans, your assessments are included in there. You also have embedded the student data records and what your students are looking at, and of course you have your answer keys and all those sorts of things. In addition to that, there's also the teacher portal, which is the web-based component of the LabLearner program. Now on that teacher portal, you'll find all of the other tools that are helpful for using the LabLearner program. One of the primary components of that teacher portal that you'll find yourself using a lot are for every single experiment that makes up the program, you will find at least one video on that experiment. These are generally used in the pre-lab portion of the program, but can also be used right in the laboratory while they're physically doing the labs themselves. And you have one of those videos for every single unit that comes with the program. Other helpful resources on the teacher portal are things like what used to be your overhead projections. Those are all digital now. So if you're using a smart board or projector, those can all be put up. Those can be used both in the laboratory and sometimes are used in pre-lab and post-lab work. As we dive into each of these days with a little bit more detail, the pre-lab is really where you're prepping them for the lab experience. There's exposure to the concepts that are going to be discussed. Sometimes you will have some physical activity or some hands-on work that will take place back in the classroom that is just a prep for what they might experience in the laboratory. The lab day is where you're physically in the laboratory. They've got their white lab coats. They are little scientists now, or big scientists if they're 7th and 8th graders, and they're physically in that laboratory. They're having those aha moments. They're learning by doing. They're working with their classmates collaboratively. They're having to communicate and discuss, what maybe went wrong or how they're going to lay out this experiment. They're really getting their content that you might find in a textbook or a web-based solution is now all happening in front of them. The post lab is one of my favorite parts of the program, and it's really something that is unique to the hands-on experience. So while they're in the lab, they may be having these aha moments and they're recording their results. It's really the post lab where we're now analyzing those results. We're also comparing what our group did to the group next to us and our peers. And this is one of the fun areas of STEM. It's discussing your results and how they might have differed from your classmates. You see that in the middle school level grades, there's this day one called a concept day. What we found over the years is that at the middle school level grades, some of the concepts are just a little bit meatier. And while you do get into the concepts in the pre-lab, it's generally exposure to that concept very specifically to what you're going to be discovering in the lab the following day. We've thrown a lot at you in this short presentation. I think it's important to sort of step back at this point and understand that all of this research-based application is happening really behind the scenes. It's all built into the curriculum so that you as the educator get to facilitate this. You get to work with the more individual needs of your students and identify who needs help, who doesn't. You get to leverage your relationship with the students and incorporate analogies that you might have of your own that help them understand these concepts. Also, I think it's important to understand that while all this is going on behind the scenes, the students, and hopefully you as the educator, you're having fun doing all of this.
See the outline of where it slipped its bone.
But I can see it. My dad got some special model paint, and every night when we went back to paint my model, that paint would be, the real paint would be on the bottom and the oil would be on the top.
And why do you think that is?
Because
What if something's really less?
I think there are a lot of fun hands-on activities, but at the end of the day, what did you learn? When we do our job properly, we're engaging hands-on to benefit from the neurocognitive research that would tell us engaging the senses is the best way to focus the students' attention and have them learn and understand concepts. And in that way, not only do they understand the concepts 2 weeks later, but they understand them 2 months later and even 2 years later. And really, they develop a lifetime understanding of these concepts. And through that spiraling, they understand how these concepts relate to each other in the real world.